Okay, today's Wednesday, February the 2nd. Today's Wednesday, February the 2nd, okay? 2222. We are going to work on our warm up. I'm going to model for you. We got a lot to model. I don't know if I'm supposed to introduce functions, exponential functions today, but if we don't get to that, then I'll do it tomorrow. Okay, this is kind of a prerequisite. I have to do laws of exponents because it's exponential functions. So it makes sense to get that out of the way first because you're going to need that as you're doing exponential functions. You need to know the rules for exponents. So that's why we're doing that first. All right, but if I don't get to actually do exponential functions today, then that's okay. We'll do it tomorrow. Okay, so I'm going to model. I was going to try to push this yesterday, but I didn't. Uh, the simplifying radicals, I have to do that today, though. Okay, I got to do that, get that out the way today. And then I'm going to try to introduce exponential functions, just a short introduction. Let me pause real quickly. Answer the phone. You can close it now. Yeah. All right. So afterwards, y'all, I'm going to give you time to finish the laws of exponent sheet that we started yesterday. Which problems did I tell you to do? Odd. So don't forget that. You're doing odd. If you finish those early, then of course you can work on your homework. Okay. Please don't forget about virtual tutoring this afternoon at 3 p.m. Okay. Take out your planner. So write this down. All right. If you did the homework last night, please make sure that you check off that you did the homework last night. Don't forget that the last day for your iReady diagnostic test to be due is Friday. That's the last day. So if you haven't finished it, you have today, tomorrow, night. That's all you have, really. Okay? So we need to get those things done. All right, so we have Math 1 homework. You're in blue. Math 1 homework. We already wrote down the tutoring. And if you haven't finished iReady, you need to write on there and iReady. Okay. Put that away. And let's work on our warm-up. I'm going to pause for the call so I can check your homework. All right, so here it says, on a map, Julie's house is located at this point right here, and Jimmy's house is located at this point. How long is the direct path from Julie's house to Jimmy's house? So what are you going to do to figure that out? Yes, distance formula. What's the distance formula? D is equal to what? Yes. And what's the other thing we're forgetting? The square root. Okay, so all you do is substitute these points in and use order of operation. Make sure you show your work. All right, Mr. Franklin needs to draw a perfect circle. So it's a perfect circle. A perfect circle means it has a true center. Okay, just to give you a visual. This is a true center. The distance from here to here is the same all the way around. All the radii, which is plural for radius, have the same measure. Okay, so it says the end point of one of the diameters needs to fall on 7, 1. Okay, and so this is basically the diameter. Okay, so it's asking you for the center. So what are you going to do to find the center? What formula are you using to find the center? Midpoint. Very good. What's the formula for midpoint? What's the formula for midpoint? Somebody different. What's the formula for midpoint? Yes.
Okay, so first it's x1 plus x2 divided by 2. And then you put the comma.
Mm-hmm.
And then you start on y, which would be y1 plus y2 divided by 2.
Very good. Okay, label your points, substitute the numbers in, and that's your midpoint. Any questions about either? All right, your homework for tonight. This is your homework. Laws of exponents. This part right here, Wednesday, is your homework. This is what we've kind of been working on. Probably the harder part, don't forget, look at number 9. When you have problems that look like this, you're going to multiply the numbers first. What's 10 times 11? 110. Okay, now let's look at each of the variables. We got G over here and G here. This is G to the third. What's this G to the what? The first. Somebody said it right. The first. So when you multiply G to the third times G to the first, what does that give you? G to the fourth. Don't forget to add those exponents together. All right, what about H to the 8 here and H to the 8 here? When you multiply, what's that going to give you?
H to the 16.
H to the 16, good job. And then we just have V to the 6 here, but we don't have any variable for V here. So we're just going to write V to the 6. Okay, so all we're doing here is multiplying. Okay, any questions? All right, go ahead and put this in your folder so you don't lose it. Take out your interactive notebook. I'm going to pause the video real quickly. All right, so yesterday we did power of a power. Okay, we did that. We did the expanded form. And then we also did fractional exponents. We didn't have enough time to do simplifying radicals, so we're going to do that today. So this is page, what page? 11. This is Q3, page 11. We are simplifying radicals. All right, this is what a radical looks like. You use the root symbol. Remember we talked about roots yesterday. You could have square root, looks like this. Cube root has a little 3 in the corner. Fourth root has a little 4 in the corner. Fifth root has a little 5 in the corner. Okay, you can go all the way up. All right, all this is saying is square root is asking you what two numbers can be multiplied times itself, that's twice, times itself, to give you the number that's under the radical. Cube root is saying what number can be multiplied times itself 3 times to give you the number that's under the radical. And the same with fourth and fifth roots, okay? All right. So now I'm going to show you how to simplify, which is basically reducing a number that is written as a root like you would reduce a fraction. It's a little different, but it's very similar. Let's suppose that we have the square root of 8. Let's do a small number first. Okay. So here, the first thing that you're going to do to find the square root of any number is to think what two numbers can be multiplied. You're going to draw a factor tree because it's not a perfect root. So we're going to draw factor trees. We did that maybe 6th grade-ish. What two numbers can be multiplied to give us 8?
4 and 2.
4 and 2. We're going to circle 2 because it's a prime number. It's broken down as far as it can go. It's prime meaning that it only has 2 factors, one in itself. 4 is a composite number, so we can break that down some more. What two numbers can we use? What two numbers can be multiplied to give you 4? 2 and 2. Again, 2 is prime, so we circle it. That's the very first step. So we have step 1, draw a factor tree. Any questions about the factor tree? When you draw a factor tree, be sure to circle all the prime numbers. Any questions about what it means to be prime? Okay. All right, now the next thing. You're going to take all of the prime numbers and put them under the radical in order from least to greatest. You're going to write it in expanded form. Yes?
What does it mean that it's prime?
That means it only has 2 factors. So 2 numbers that can be multiplied to give you that number. 1 and itself. Does that make sense? Okay. We're going to take all of the prime numbers, all of the circle numbers, and put them under the radical in like expanded form. So that's going to be 2. And sometimes they say exponent form. So that's going to be 2 times 2 times 2. It's 3 2's. So now here you're going to look for numbers that repeat twice. You're going to look for pairs. You're looking for pairs because it's square root. You're looking for a number that can be multiplied times itself twice to give you the number that's under the radical. So you're looking for pairs. If it was cube root, you'd be looking for numbers that repeat 3 times. If it's fourth root, you look for numbers that repeat 4 times. Since it's square root, you're going to look for numbers that repeat twice. So what number or what pairs do we have?
2 and 2.
Okay, so we only have 1 pair of 2's. Circle that 1 pair. Okay? So second step, step 2, you're going to look for pairs. That means numbers that repeat twice. You're going to take out 1 number for each pair. I'm going to take out 1 number for each pair. Okay? This is the second step. So since you have 1 pair, you're going to take out 1 2. You don't have any more pairs, so all the numbers that are under the radical or left under the radical, you have to leave them there. What's left under the radical? 2. Here, this is going to be your answer. This is like reducing this root or radical. Suppose you took out more. No, did you have a question about something? Go ahead. What's your question?
I was a little confused on how you got that.
How I got the what? Let's back up. You understand how I got the factor tree?
Yeah.
Okay. Do you understand that you take all of the circled numbers and put them under the radical? 2 times 2 times 2 is still equal to 8. 2 times 2 is 4. 4 times 2 is 8. So you're really writing the exponent form of 8, basically, or the expanded form. Does that make sense?
Yeah.
Okay. Then, once you put them under the radical, this is square root. Square meaning 2. So you're going to look for numbers that repeat twice. 2 repeats twice here, so that's 1 pair. So since it's 1 pair, you take out 1 2. But go ahead, talk.
Oh, okay. So you took out the 2 and then you did the 2 and then next to the square root of the other.
You leave the other 2 This is the remaining 2. You don't have another pair for it, so you have to leave it there. Do you understand that part? Okay. Somebody else had a question. Go ahead, baby.
Does the 2 outside of the radical show that it is square root? Like if that was a different number, say that was an 8, would it be 8th root showing that in the answer?
Say it again so I can understand.
The 2 outside of the radical, is that showing that it's square root of 2? It's like if that was a 3 or a 4, would that be cube root or 4th root? No.
Yeah, I got what you're saying. No, that's not what that one means. This is going to be 2, the square root of 2. And so in order to put it, you know how when you look at your calculator, clear your calculator real quickly. 2nd plus 7, 1, 2. Okay, you know how when you have the decimal form of a number could be 0.5. What's the fraction form of that number? A half. You see, you press math, enter, you see, and then you get a half, right? All right, so let's type in the square root of 8 to see what decimal we get for that. This is the radical form of it. Let's type that in, okay? So we have square root 8. And what decimal do you get there?
2.82842.
See that? Do you see the 2? The 2? You see right here? The 2 right here? Do you see that? Okay, that's the 2. That's the whole number 2 right there. And then you got point, blah, 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 whatever. That's that square root of 2. Okay, just the way to think about it. Now let's type in 2, the square root of 2. So we got 2. This is how you type that in, 2. And then you type in the square root because it's automatically multiplication between the 2 and the square root anyway. You can put multiplication there, but because there's no sign there at all, it automatically means that you're multiplying. So now you're going to put 2 square root of 2, and you can close the parentheses and press enter. What do you get there? The same thing. So anything I'm really doing is showing you how to reduce it. Do you understand?
Yeah.
Okay. Anybody else on that? You okay? A little shaky?
Yeah.
Okay.
It's not
Might not click on this one. Let's do another one. If still don't, then just tell me, okay? You might have to see more. Say again. Oh, okay. All right, so let me finish with the rest of the steps. The more numbers, whatever you take out of, if you took out more than one pair, then you multiply all of the numbers that you take out together. All of the numbers that are left under the radical, you multiply those together. This one is very simplistic, so you didn't have to do that. But for some other ones, you're going to have to do that. Okay, so I'm going to give you some examples. Let's do step 3, just in case we ever have a step 3. You're going to multiply all of the numbers you take out from up under that radical. Just going to put you take out, keep it simple, that you take out together. You're multiplying those numbers that you take out together. Okay? Period. All the numbers that you take out, all the pairs, all the numbers that you take out together. If it's more than one pair, you're going to multiply those numbers together. Now, there's only one number left under the radical here, but if you had more than one number left under the radical, you're going to multiply those numbers together as well. So you're going to multiply all of the numbers left under the radical together. And it's going to help when you get a visual when you see it, okay? Under the radical together. Okay? So now you need to see some examples. Okay? That's not going to make a lot of sense to you until you actually see it done. Raise your hand if you're still writing. Okay, let me pause. Let's try it. Let's do some examples. This is still page 11 continued, okay? You probably have more space than I do. I wrote kind of big. Okay, so let's do one that's a little larger. Let's do the square root of 80. Let's do 50 instead, so you don't get fixated on 8. Let's do 50. All right, so first things first, we draw a factor tree. What two numbers can be multiplied to give you 50? 25 and 2. Okay, we're going to circle 2. Why am I circling 2? Because it's prime. You can't break it down anymore, okay? So now we're going to break down 25. What two numbers?
5 and 5.
5 and 5. What kind of number is 5? Is it prime or prime? So we circle those as well. So we know 5 times 5 times 2 is equal to 50. Any questions about that? All right, so next step. I'm going to write this here. Okay. I'm going to put all of the circled numbers under the radical. Okay, I'm going to put them under the radical, but I'm going to put them in order from least to greatest. Yes. I do. On my back, behind my desk, on the little roller cart. So I'm going to put this in order from least to greatest. So smallest prime number is going to be what?
2.
So we got 2 times what?
5 times 5.
Very good. And this one's a shorter one. I should have chose a longer one. All right, so when I do that, after I do that, I write the prime factorization for that number. I'm going to look for pairs. What pairs do I have?
5 and 5.
5 and 5. So how many pairs is that? That's just one pair, right? One pair. So I'm going to take out 1 5 for that one pair. What's left under the radical? 2. Any questions about that? Elijah, how you feeling? Still a little shaky?
Yeah.
Okay. Go ahead.
I still kind of don't understand what, like, the 4 and 5 is in front of it.
Say again. Are you confused? You got this part. You say you got that part. You understand that I put that under the radical sign, right?
Yeah.
Do you understand that I'm looking for pairs because it's square root? Does that make sense to you?
Yeah.
So do you understand, because it's a pair, like a pair of socks. Okay, I got 1 pair of socks. I have 1 pair of 5, so I take out 1 5 to represent that 1 pair.
Oh. Okay.
And then whatever is left under the radical, I leave it there. Because it doesn't have a pair. It doesn't have a mate. There's no mate for that, so leave it there. Do you understand that part? Okay. Peyton, go ahead.
Is it because of the same number they're up there?
Yes, it's because they're the same number. Like when you mate socks, they're exactly the same. They're twins. Okay? All right, let's do another one. Let's do the square root of 180. What's the first step? Factor tree. Very good, Peyton. What two numbers can be multiplied to give me 180?
92.
90 and 2. 90 times 2. Okay. What is 90 prime, or is it composite? We can break that down some more. What about 2? Prime. Circle it. 90, let's break it down. What two numbers?
45 and 2.
45, you want to use 45? That's fine. 45 and 2. You can use the other 2 that you said. You're going to end up getting the same answer at the end if you do the math right, okay? You can use any 2 numbers as long as when you multiply them, they really equal that 90. So we got 45 and 2. Circle 2 because it's prime. Break down 45.
5 and 5.
Okay. Circle 5 because it's prime. Break down the 9. 3 and 3. Circle the 3s because they are They are prime. Very good. So now, prime factorization for this number. Remember, we're going to write the numbers in order from least to greatest. This is going to be the easiest way to pick out the pairs. So how do we write this from least to greatest? Okay, we got our 2's here, 2 times 2. We got our 3's here, 3 times 3. And the last number you said was 5. Just want to make sure I get them all. So 2 times 2 times 3 times 3 times 5 is equal to 180. Okay, so now, yes, baby.
I didn't use 45 and 2. I used 10 and 9.
You still should get the same answer. If you use 10 and 9, just make sure you break down both the 10 and the 9. You're still going to get the same combination of numbers. Got it? Okay. All right, so now what's the next step? After I write everything under the radical, what's after that? Yes.
Find your pairs.
Find my pairs. What pairs do I have here? 2 and 2, 3 and 3. So how many numbers do I take out for each pair? Okay, very good. What's my first pair?
2.
So I take out 1, 2 for this pair. What's my second pair?
3.
So I take out 1, 3 for this pair. Do I have any other pairs?
No.
So I leave the other numbers under the radical. So what's left under the radical?
5.
The 5. This is where that third step comes into place. All of the numbers that I take out from the radical sign, I multiply them together. All of the numbers that are left under the radical sign are multiplied together. So what numbers do I multiply together? And what does that give us?
6.
So we have 6, the square root of what? 5. Okay, Ian, you got it? You sure? Okay, Sammy, you write this down? Poor Sammy. Sammy, I know I get on your nerves. I'm sorry. All right, square root. Ready? Let's do this one. Let's do 90. I really want to do, I'd rather do 120. I'd rather do 120. All right, 120. What's the first step?
60.
Factor tree. What two numbers can be multiplied to give me 120?
60 and 2.
Very good, 60 and 2. Ian, did you have a question or you was? Okay. We're going to circle 2 because it's prime. Now let's break down 60. What two numbers can be multiplied to give me 60?
32.
30 and 2. We're going to circle 2 because it's prime and break down 30. And again, Donnie, it's okay if you use two different numbers, okay? You should get the same prime numbers, okay? So what two numbers can be multiplied to give me 30? 15 and 2. Circle 2 because it's prime. Y'all love 2. What about 15? 5 and 3, 3 and 5. Okay. So now, move my screen. So now what numbers are we going to put under the radical in order from least to greatest?
2 times 2 times 3.
So 3 2s, I got those. What else? A 3 and a 5. Okay? All right, good people. What's the next step? Find the pairs. What pairs do we have?
2 and 2.
2 and 2. Are there any other pairs?
No.
No, there are no other pairs. Okay, so what's my next step?
Multiply the numbers.
Before I can multiply anything,
You
what
gotta put it
Oh, you have
on
to
the
take
outside.
out 1, 2.
you have to take the pair out, right? How many numbers do I take out for that pair? So I take out 1, 2 for this pair of 2s. And now there's no other pairs. So what's left under the radical?
2, 5.
Very good. 2, 3, and 5. All right. So now what do I do? Multiply. What numbers need to be multiplied?
2 times 3 times 5.
Very good. 2 times 3 times 5. So we got 2 to the what power?
30.
30. Elijah, how you feeling?
I'm good.
Okay. All right. You good? Hatcher, what about you? You sure? Okay. All right. So are you ready to do a couple on your own?
Yep.
Okay. And then I want you to work on those odd problems. Remember? Y'all got that sheet? Anybody not get the sheet from yesterday? You need another sheet? Okay. Anybody else need another sheet from yesterday? Okay. All right. See if you can do these on your own. Yes, baby. You need a new one? Okay. All right. I want you to do these on your own. Can't see it. All right. These are the ones I need you to do on your own. And I'm going to pause for the pause. All right. So let me give you the answers to these, okay? So the first thing that you do is draw a factor tree. Okay, so here you can say 3 and 25. Okay, you're going to circle 3 because it's prime and break down 25. You can say here 5 and 5. All right, so now you're going to take all of these prime numbers and put it under the radical in order from least to greatest, just like I told you. And it's 3 times 5 times 5, and it's in order from least to greatest. Now you're going to look for pairs, okay? So your pairs here are going to be the 5s. You're going to take out one number for each pair. So you're going to take out 1 5. What's left under the radical? The 3 is. And this is your answer, okay? Let's do the next one. I'll do the same thing. What two numbers can be multiplied to give you 300? You can say 3 times 100. You can say 30 times 10. It doesn't matter, okay? If you break down 30, you can say 5 and 6. 5 is prime, so circle it. 6 is composite. That's 2 times 3. These numbers are prime, so you circle it. 10, you're going to break that down to 2 times 5 and circle it. You're going to take all your prime numbers and you're going to put them in order from least to greatest. So you have 2 2s, you have 1 3, and you have 2 5s. Okay? All right, so now you're looking to take out pairs. You have a pair of 2s, so take out 1 2 for this pair. And you have a pair of 5s, so you take out 1 5 for that pair. You leave 3 under the radical. Whatever you take out from under the radical, you multiply together, that gives you 10. So you have 10, the square root of 3. So 450. What two numbers? You got 45 and 10. Okay? Write down 45, that's 9 and 5. Circle 5 because it's prime. For 9, that's 3 and 3. Circle 3 because it's prime. For 10, you have 2 and 5. Circle both because they are prime. Under the radical sign, from least to greatest, you have 2. Then you have 2 3s. Then you have 2 5s. Okay? You're going to take out pairs. Look for pairs. You have a pair of 3s and a pair of 5s. Take out one number for each pair. Take out 1 5 and 1 3. What's left under the radical? The 2. 3 times 5 gives us 15. So it's 15, the square root of 2. All right, y'all. Have a lovely evening. Thank you.